here is more for the heuristic one, meaning that it's hard to analyze, so use a bit different way. Yeah, and actually make it easier. So here, actually I like this name better, engineering optimization better than optimization math. Yeah. So it's more and more about engineering, and I should not start from here actually. I should start with the FPS. This optimization math, only 2 credit. And it's mandatory, which here you learn about optimization technique with a nonlinear function, either for single variable or multivariable. So this is the main part. Yeah, the nonlinear. Most of the linear one is the Newton operational. Nonlinear meaning if we put in a graph x and y coordinate, it's not necessary. Yeah, usually it's actually more difficult to do analytically, so usually people use different approach. Because curve is more difficult than just right, to analyze. So here, and this is what we learn now today is this introduction, and then some of the criteria for a single variable, and then there is something related about where to find one challenge, which is the solution area, and we learn about what is constraint, what is concave, and this is starting to find a solution. If it's single variable, could be finding within the area or using the differential, and then still 2 weeks of that, and then start about multivariable, which is a little bit variable, more complex definitely, and then start with all the multivariable finding space, differential, and then curiosity with the Lagrange, and this upper finish. Yeah, this is more technical, but this is what we have. And basically everything in here in simple terms is optimization. Yeah. The book this is the main thing, or if I can use the GPT is yeah, Ravindran, Maxwell, and it is the engineer optimization, or any newer edition, and you can find it online. I mean, mostly this is textbook. Here. Now, so I'm gonna give this introduction about this, because this is, you've been learning the basic since you studied 1 year last year. We got math, physics, chemistry, we also got linear algebra. Now it's more industrial engineering. This starting this semester you should feel more industrial engineering. Yeah, this is one of them, and the other classes. So this part of this type of classes, optimization, laboratory research, and international, it's, I think, the backbone of industrial engineering, specifically industrial engineering, not engineering management. I often tell to students to differentiate between industrial engineering in here in Indonesia and outside, like in the USA, for example. In here, what we have is actually a combination between industrial engineering and engineering management. Because if you see the curriculum book, you have engineering management department, but we don't have it here. So you meet and this class and also personal research class is the backbone for the industry. So the one that has more calculation, while management has more survey based on the interview. In here, it's hard calculation. Yeah. So if previous semesters you enjoy linear algebra or math, then it's good that you have the basic. But if you did not enjoy much, then you need to catch up. Because they are the basic for this classes. Yeah. Right. Okay. Again, before here, so who's the class? So at least later, WhatsApp is until I will change your name.
Okay.
I already saw your name, but I don't know which one should I contact.
I think Ahmed is capable for this.
Okay. Alright, so yeah, I will change that. And so I will always try to share you, or if I cannot attend the class or using Zoom. This Zoom has no camera, so if it's using Zoom, then it can be anywhere.
Okay.
Any question before we start more detail about optimization?
Engineering optimization, is it more used by statistics?
Statistic. Not exactly, but using the result from statistics.
So we study about the fundamental.
Yeah, the basic is mathematics and linear algebra. Okay. Since you asked that, let's read this. Yeah. So, body of mathematical and numerical methods for. So there's another branch which is numerical method. Yeah, in other department. But in this case, yeah, finding and identifying the best candidate from a set of alternatives without explicitly enumerate and evaluate all possible alternatives. So this is actually basically you have as an engineer, you should have a problem or find a problem within the organization, within the factory, if you work with them. Yeah. And as an engineer, especially industrial engineering, then after finding the problem, you need to find solution. But the purpose is to find solution for the problem. But how, using this optimization, you transfer the problem that is from interview, from survey, into a mathematical model. And so then you can analyze to get solution. Then you have this finding and identifying best candidates set of alternatives of that solution. So you have several solution options. Yeah. And the solution based on the name optimization, the best one is the optimal solution. But usually it's not easy to find optimal. So near optimal is really hard. Just that the first try you have a bit far from the optimal, second iteration closer, third iteration even closer, and fourth maybe the optimal one. So basically this alternative is usually closer to the optimal one. But sometimes we will stop before optimal because reaching optimal will be too expensive to too time consuming, which is too difficult, meaning that too expensive or too time consuming, and we don't have the time to do that. So just stop at the third iteration, for example, and that's it. This is near optimal, it's fine. Yeah. In essence. Then, and we will go to the example later. That's the essence. And then they say about the rule of engineer: design new, better, more efficient, less expensive, which is getting better, as well as to devise plans and procedure to for the improved operation of existing system. This is, so that problem you design. With that problem, your solution is kind of to design better configuration. So it's maybe I'll give you an example. There's a problem, for example. You go to a factory, you're either a student who research there or you work as the staff. Then you find that, this product, it's almost always late. The deadline should be what day, what time, and most of the time it's late. So that's a problem, for example. So you try to find, let's try to find the source of the problem. What is it? Yeah, could be anything. Could be, the worker that did good. Could be the procedure, work procedure, or the operation procedure, SOP, standard procedure. Could be the machine that is old. Could be the scheduling. Could be anything. Could be even the supplier, raw material that actually they're late and they're causing everything to come in. Could be anything. But once you find what's the source, then you can try to formulate to find a good solution. Yeah. Okay, for example, apparently the cost is, the product is actually from 100 that is being made, only 80%, 80 items is good, the other 20 is bad. So there are some defective product, and then we cannot deliver on time because we need to wait for the other 20 to replace those bad 20 product, and you need to wait for that before delivery, for example. Now, then with another method, you try to find, how can we get this non-defective product to be more, or the defective product to be less? So how can we do it? So there is a lot of way, but for example, apparently it's because of the working, how can I say that, schedule that is not good. So most of them, they are in a hurry, or the worker in a hurry, or sometimes there is not enough worker, so they got pressure and then make the product effective. So in conclusion, the solution should be to have a new configuration. Configuration means, for example, if I want to make a product, I need human, I need machine, I need raw material, and other things. Say only these three, for example: human, machine, and raw material. Yeah. So then configuration means, to make 100 product, I need how many people? I need how many machine? I need how many raw material to make a good product? And if that's the solution plan, then you will try to find a new configuration, which is this with the design, a better one. Yeah, previously only 5 people, apparently you need 9, for example. or the raw material. Previously you need what 100, now actually with 150 because the raw material, some of the material are not good enough. So, one example. So now you're designing a new configuration to find how many people or many should use better one, more efficient, more actually before efficient should be more effective. Yeah. Effective is to make something exactly what you need. You need 100, then you have good product 100 good product. While efficient, to make that 100 good product, usually you need say 10 days, now you can reduce to 7 days. That efficient. And the difference. So before efficient should be effective. Yeah. Less expensive, this is also used a lot because in the industry you want to get more profit by easily reducing the cost. And yeah, so this is one example of what is meant by good. Any question for that example?
Are we going to like solve from like a study case?
It will be, but in here, actually they make it more simplified in this class. But in the operation research class, in penelitian operational, then we will have more complex.
So we need to solve like the problems.
You need to model the real world into mathematical problem, then solve it. In here, actually same, but they make it simplified to how to find a solution for non-linear. So I think it's actually, if you want to be in sequential, operation should be first, then this is second. Not they must be one semester. But I think still okay. Because you need linear algebra. Math, previous math. Yeah. Power of optimization method determine the best case without actually testing all possible cases. Come through the use of a model's level of mathematics and at cost. So, this is not doing actually like you want to reduce from 10 people into 8 people only to work in this factory. In here, you just change the number. But if you apply, actually you need to fire those two, right? So firing people is not easy, or moving the people to other departments is not easy. So using this is actually much easier. Yeah, and you can change. Okay, reducing from 10 to 8 people might be not good idea. Let's change it to 7. Or let's make it just 9 people and only one get fired. So you can change easily, like simulate easily. Yeah. The best decision then you want to apply to actually apply it after consideration from the management, firing or laying off people or moving them to other division is not easy. Yeah. So this is the power of optimization. Requirement to apply optimization. Yeah. Because finding solution, this is one way. There are other ways that you will learn more as you progress and you study. But to apply optimization, this is what you need. Clearly, delineate the boundary of the engineering system. So you need to be aware of the boundary. You have a problem, but you want to make sure what is your boundary. You cannot solve a problem that is too complex. Actually, you should start from something small. Yeah. Then make it more complex. You should set boundary first. Are you trying to solve one project, one factory, or one company? Definitely company is too complex, right? So you need to make sure, and even one factory is too complex too. Which workstation? you close the door? Because this is live session, so system.
Kamusta?
If it's open again, then you might want to lock from inside. Do you have the key
Oh, right.
attached to the door? I think this where is that? It's not here. Just try to close it as
You got to like it. Oh, yeah.
This is a problem. Okay, good. As best as you can. It's okay. It's okay. Oh, we have an idea.
Have you put like a paper on it?
Can you? No, it's okay.
What
It's
is it?
okay. I'll ask for the email or
Buat taruh di bawah.
or change. That's fine.
Okay.
For now. Then define quantitative criterion objective. So to do this, to do optimization, you need to be able to define the criteria. Like what is your objective? There has to be one or two main goals. So what's your main goal? Is it to reduce costs? All those configuration, all those decisions that you want to make, is it to reduce costs? Or to increase service level? Or to reduce defective product? Or anything? Yeah. What's the goal? So everything else is toward that goal. Yeah. And then select system variable. You need to also what's to select to describe to choose what's the variable. What is variable? We basically like my example. That product is a human, a worker, the machine, and then raw material, the number of people, the number of machine, the number of raw material. That's the variable. Yeah, that's the variable. So you need to choose which one. Of course, small variable are better because it's more complex, but that also means that it's too complex to solve. Yeah. So start little, then add more. And define a model for expressing the relation of variable, and yeah, of course, those variable you will make as a mathematical, yeah, like add or deduct, depend on the problem. Boundaries. So what does it mean by separate the system from the universe? Universe means the actual world, actual from the whole company, and yours, the system that you are now analyzing is just this workstation. This is, you need to separate that. Yeah. This system is part of the universe. This workstation is part of the whole company. But you are analyzing this, focusing on this. Yeah. Initial choice may be too restrictive because when you choose, usually it depends on what you experience. Sometimes, only one workstation is not enough. You need to have more. But which workstation that it should include then? Yeah. So that's also you need to understand the business system of the or the relation between one workstation with the other workstation, and then you will include the other. By workstation, I mean a machining section. Okay, that's welding section. Yeah. Other is painting. That's one area. Yeah. Then expand the system boundary, increase in size and complexity after you have the solution. Start small, find solution. If it's good solution, then expand. add additional variable. Finally get solution again. Until you get solution, then you can add another variable. Don't add when you cannot find the solution. Because even if you add, it won't be nothing. The more simpler model you cannot solve. Example, manufacturing operation has a paint shop in which finished parts are mounted on an assembly line and painted in different colors. So there's a part that mounted on an assembly line and will be colored. Optimize batch size or color sequence. Batch size means per process, in one process, a group of items being processed at the same time. Yeah, say a box of 10 items to enter one machine, that's a batch. Yeah. And you can change that batch into 20 or 30. So one entrance, batch size. Or just one, that means not batch. Yeah. It's only one individual. Or the color sequence. So this is an example. So now, how to optimize? How should be the batch size? The problem now is the manager doesn't know, or trying to find the optimal batch size, and you are as the staff or the student that work there being asked, so how many parts should we use? 10, 15? So, so for that, we need to do this to make sure that you know what's the performance criteria. So what's the goal? That batch size, if you change, if you suggest, what is the goal? What is the effect of changing that batch size? Okay. Could be cost. Usually it's the cost. Yeah? What do you want to do? To maximize or to minimize? Cost, ROI, or time, or production rate. Say, usually cost you want to minimize, right? But production rate you want to maximize. Time you usually want to maximize. It depends what the goal. You need to ask your manager, what is your goal, what is the target by this batch size. Okay, make sure of that. And only one criterion for now. Sometimes we can have two, but now only one. One criterion is limited to this. Minimize or maximize something. Okay. And yeah, this is an example, different view, different department. For shop foreman, the criterion, performance criterion is to design with minimum color change, because more changes, that means more time, more complexity, more chance to get defective product, because you need to change too many color, too many settings. While for the sales department, maximize inventory of part. And they try to use the most inventory that we have, because maybe they want to resupply to make the flow quicker for the sales, so they can quickly sell, for example. But financial officer, they prefer actually to minimize inventory, for example, because the inventory needs more money. So several people have different view. So that means that's why you need to, as a staff, you need to discuss it. So which one? Which one? Yeah. If you're the manager, then you need to discuss with the other manager, of course. That's management level. Yeah, you're not in that part yet to discuss. Okay. Now, speaking about variables, so actually there are two variables, independent and dependent variables. The independent variable is the one that you don't, it won't affected by the other variable, but dependent is will be affected. Yeah. So what I give you example about variable is the number of people, number of machine, the number of raw material. Yeah. That, for example, are independent variable. But the number of product being made is dependent, because it depends on the number of people, the number of machine depend on the number of raw material. Yeah, so that's dependent. Okay. So you need to be able to separate which one is the independent, which one is dependent. Yeah. Then, this is system model. The model means the relation connection between those variables, and there is one more. It's parameter. Parameter means the constant. So if variable are the number of people, the constant might be the salary. If your goal is to reduce the cost of producing goods, that means you need to look those people as money, that's salary. You need to look those raw material as money as well. How many we should buy from the supplier. And you need to look those machines that you use as money as well. How much to operate, what's the electricity bill or gasoline depending on the machine. So that's the parameter. And then we mix those variable and parameter into mathematical expression. Yeah. Which actually we will learn more in the operational research. But more than good in here, we use it as simpler. Yeah. Because real system is too expensive. Now go straight here. Here we go. Engineering design. So this is when you find a problem. This is one common way chart. Yeah. The recognition of needs and resources. You know what do you want, what do you need, and what's the resource that you have, and then you find could be the problem definition. What's the actual problem? Okay. What's the problem? And then based on that, you develop the model based on what you need and what's the problem. Then you analyze, compute, then optimize, like to increase the complexity. Okay. Okay. The chat is okay.
Yes.
We'll come back to the previous example. This is some example of optimization, which okay, I'm gonna skip this. I'm sorry, there was an example before. Now, and you will be using this heuristics, which is algorithm that construct feasible solution and thus upper bound for optimal value. We haven't learned about upper bound. Basically, how can I use an example? If you're in math, you can calculate based on the formula. Say what? Okay, like this. You have several equations. which you can put this several equation into graphical form, and x and y axis. And then those lines will intersect, and then you need to find this intersection.
Stationary.
So in math, you just, do you know how, do you still remember in high school how to find the intersection point between two equation? You still
Gradient.
remember how to find, this is like, I don't know, this line,
Yeah,
little line,
gradient.
and something, this line, and you need to find the intersection. Yeah, it's actually x and y in that dot is the same.
Yes.
Yeah, the x and the y the same. So using that, then you analyze and get that point. But heuristic, it's used same to find where this point, but not using that line. It's like you draw another line and you move this line. Oh, this is not the answer, this is not the answer until you reach the answer. Imagine you move this, you move another new line, you move this until you find the optimal one. This looks like a longer process. Yes, it is longer for that. But if the line is not 2, but if the line is 500, you want coordinate. What is the line is 1000? You want to use the other math like you maybe too long. You use the heuristic, you just draw a new line, just move it and see what happens every scale that you move until you reach the best one, maybe near best one, near optimal. It might be faster. Yeah, that's the heuristic. Basically like that. Different way to find optimal or near optimal solution. Yeah. It's actually for a complex system, it's more cheap and it's more fast. Yeah, I think it's more fast. That's realistic. And here, this is the mathematical model that we will need to make first actually. You have minimized fx as mathematical formula for the main objective to minimize something, say cost. So fx is an equation that consists of several x, as a function that you want to minimize by what? Changing the x. And how can you change? It's based on this subjective. So there are several equations under. It's basically to find boundaries. Say that x is the number of people that you want to use. It's not unlimited. In the one company, you only have say 50 people. You cannot have more. So that's the capacity. Like machine as well. You only have 10 million machine. You cannot ask for 11 because you don't have it. So that is the boundary. That's why it will be equal to, bigger than, or less than. Yeah. And also, what is x? You cannot ask for a negative 5 people. It has to be 0 or more than 0. Right? And you can ask for a 1.5 people. Because one people, you can try to. Yeah, that's one example.
Sir, can I go to the bathroom?
Yeah.
Thank you.
So this is that you will need to sometimes there are no constraint. Unconstrained optimization problem could be what an example of the unconstrained. Is there anything that you can use freely in a factory? There could be some example. Yeah. One example, the power time. In Python, for example, you get electricity from them. They want to work 24-hour day. They want to work only 5 hours a day. Up to them. It's just that now, if you 5 hours, you don't have electricity now, right? But it's really up to them. They could reserve the power so that they only need to work not 24 but 22 because they use the 2 hours for reserve. For example, and there could be product unconstrained, but rarely, yeah, mostly it's constrained. That's why it's like this. Unlimited. Using L, let's discuss later. Now, yeah, this is yeah, for several objective, could be linear, could be non-linear. Yeah, we will have probably the non-linear. Some linear. But also research will be here about the constant are mostly linear. The variable, yeah, could be both. Yeah. Then the program, meaning the method that you're going to use, the type of the model, could be linear individually or linearity or this quadratic program or fractional linear. Yeah. Now we have another problem. This one. Let me check. Okay, yeah, this is good. This has an example. There you go. Now this is another example. The refinery process crude oils to produce a number of raw gasoline intermediate that must subsequently be blended to make 2 grades of motor fuel, which is regular and premium gasoline. Yeah. So the oil need to be set up to make these 2 different products. One is regular, one is premium fuel or gasoline. Each raw gasoline has a known performance rating, has different characteristics, in this case performance rating, a maximum availability, the capacity or how many do they have, and a fixed cost, different cost in processing those. So you start to see there are some variable there. Yeah. Or actually parameter, which is the cost. 2 motor fuel have a specified minimum performance rating and selling price. Now you have selling price, you have performance rating, and their blending is achieved at a known unit cost. Then another information about the cost of blending this. Contractual obligation, this is the regulation, minimum production requirement of both fuel. There are some. At least you have to produce this amount. As an example of the restriction that at least you have to produce. You cannot produce less than this amount. You can produce 0, for example. However, all excess fuel production or unused raw gasoline amount can be sold again. Can be sold again at a known price. The optimal refinery production plan is to be determined over the next specified planning period. See, this is an example of the problem. What should we do? What do we know and what should we do? Yeah. So what's being asked here actually? Right? What do you think? There is so many things that just there is no number yet. Behind, of course, they really know the cost. There is a fixed cost of the dollar or rupiah, availability, how many liters or gallon, but production plan. Well, what's the variable? Most of the time, you need to discuss it with the manager to make sure that this is what the manager wants. you have some guesses. Yeah. One good guesses is to actually, so how many that we need to make the regular and how many gallon for the premium. That's the good guess, but maybe that's not the case what the manager wants. Yeah. So with this, progression plan is schematic. This is the raw gasoline intermediates becoming regular and premium. So I think this is a step that they can sell it until the end, but then they can make some premium and some regular. Yeah, because you might also want to sell the raw material. It's remember that they can sell the excess fuel or unused raw gasoline. So if you already use for regular and you still have unused, then you can sell it. So this is an example of the scheme. Yeah. And once you make some regular, some gallon of regular, some gallon of premium, then you sell to the market as a product. Yeah, a specific product. Well, this is still raw. Yeah. So what's the system? We have raw gasoline intermediates, we have blending operation, we have the fuel, the motor fuel, and after you ask the management, oh, they actually want to have this net profit over planning period. So the manager want you to maximize the profit. Yeah. Of course, finding how many you should make, but the main goal is to maximize the profit. Yes, then because you have sales that minus which profit mean the sales minus blending cost minus cost of utility. So this is also need to be make sure that this is the formula for the profit that accepted by the manager or not. Yeah. This is much simplified. Yeah. Okay. What time do we have? What time?
25.
One. So here are the goal. The system, the performance index or the goal is to maximize the profit by this formula. And then what's the variable is here. Amount used for regular, amount used for premium, and how many should be sold.